Hi, today we are going to explain circle. When we look at this chapter, I'm going to go very fast with this, so we don't waste too much time. This is a circle, and you know that the circumference of a circle is given by 2 pi r, and its area should be given by pi r square. Now, suppose you've got a radius here, okay, and if you want to find, this is 7. Of course, now if you want to find the circumference, you're going to say 2 pi r, and pi is taken as 22/7 times 7, and that's going to give you 44 centimeters. You might have come across this many times in your previous lessons. And if you want to find its area, nothing difficult, so we're going to say pi r square, which is 22/7 times r to the square, and that's going to make it 154 centimeters square. Now, the other thing I want you to know about circle is, for instance, if you have a circle like this, and I cross this by a chord, this is called a chord. Of course, this is going to be then your major segment, and this one is the minor segment. Some properties of circles. Okay, you can have a circle like this, and now you've got, say for example, a portion of that circle is taken out. This is the minor sector, and this is the major sector. The reason I'm doing this is because I want to help you how to find the area of a sector. Of course, this is r and this is r, and you've got an angle here which is called theta. Now, if you want to find the arc length and the area of a sector, how do you do this? Let me just give you a sector like this. And let us say that this is theta, this is r, and this is r. Okay? I'm going to come back to this later on. So for this, how are we going to find the arc length? This is, let's say this is OAB, and I want to find the arc length of AB. Well, this is given by theta over 360 degrees times 2 pi r. And for the area of the sector OAB, we are going to take theta over 360 degrees times pi r square. So this is a very important formula that we use throughout circle to be able to find arc lengths as well as area of sectors. Now, let's take an example. For example, if I give you a sector like this, let's say this is O, X, Y, and I give you this as 36 degrees, and say that this is 12 centimeters, and I want you to find arc XY. That's the first part, and for the second part I want you to find area of sector OXY. Okay, the first part is very easy, as well as the second part, so the answer to this question is going to be XY is equal to 36 divided by 360 degrees times 2 pi r. 2 times pi times r, and r is 12. So, you can just plug all these values into your calculator and you will get the answer. Sorry. We're getting 12 over 5 pi, which is basically approximately 7.54 centimeters. Right, moving on further, I want to find the area of the sector. So the area of sector OXY y, that should be given by 36 over 360 times pi r squared. There we go. Okay, so again we use our calculator. And we are looking at 72 over 5 pi. And this is translating into 45.238 and so on. I can say 45.2 centimeters squared. Excellent. Now this is very important for us. Why? Because we can take this a step further. What I mean by this is, if I draw a chord here and I want to find the area of this segment. Okay, suppose I want now area of segment. The segment is, let's say, xy, let's say xzy, okay? So xzy. So basically what I'll do, I'll take the area of the sector, minus the area of the triangle. This is a triangle. Minus area of triangle. Now I'm not worried about the sector because I found the sector. Here we are. That's the area of the sector. I need the area of this triangle. I have a triangle like this. So I can find its area. If this is 36 and this is 12 and 12, I can use sine. So area by trigonometry, area of triangle xy, OXY should be equal to half 12 times 12 times the sine of 36 degrees. I'm sure you will know that if you have a triangle like this, okay, let's say A, B, C, you got A here, you got C here, you got B, and there's an angle of theta here. I want you to find the area of this triangle. The area is going to equal half BC sine of A, or sine of theta. This is what I've used to find the area of this triangle here. So now I'm going to switch my calculator back into the degrees mode. So I'm getting 0. This times 12 times 12 times sine of 36. And from here I'm getting something like 42.320538. Okay, and that doesn't really make sense to me. The reason being, no, that makes sense. I thought it was 45. 42, that's fine. That's good. That's good. So now we're going to find the area, the area of the segment. It's going to be equal to all of that, 45.238 and so on. Take away 42.320,538 and so on. So let's do that in our calculator. 45.238, take away 45.238, take away 42.321. I'm getting 2.917. So to 3 decimal places, if I want to give the answer to 3 decimal places for some reason, let's say in the exams they tell you 3 decimal places, here we are, centimeters square. So that's the shaded area. Take care.